So let's go over some basic rules that we need for indefinite integrals. If we write this indefinite integral relationship, it just means that if we took the derivative of this a of x plus this constant c, we would end up with whatever was inside the indefinite integral symbol here. So the first basic rule we need is a power rule. A power function is one that has the form f of x equals x to the k, where k can be absolutely any number. And the rule is that if you look at the indefinite integral of x to the k dx, so we end up with 1 over k plus 1 times x to the k plus 1. And this is valid as long as this k that we're looking at is not equal to -1. So we'll need to check that carefully when we do this. So let's look at some examples of what this would look like. First basic one we're going to look at is what is the indefinite integral of x to the fourth dx. So the first thing, I just need to recognize that I'm actually in this form where I have an x to the k, and then it's going to be pattern matching. So here the value of the k, the power is 4, and so I'm going to do 1 over k plus 1. Well, k plus 1 would be equal to 5. So then I go 1 over 5 times x to the fifth plus c. And this 5 is coming from the fact that k plus 1 here was equal to 5. Okay, so for this next one, what is the indefinite integral of x to the pi dx? So again, we're just looking at pattern matching for the rule. Can we identify the value of k that we would need to go forward? So here the k value is equal to pi. So that means that the k plus 1 value is just equal to pi plus 1. We're going to have that this is equal to 1 over pi plus 1 x to the pi plus 1 plus c. This would be our final answer. The whole point is that pi, although it's a special number, it still follows the same rules as 4 did. What is the antiderivative, or the indefinite integral, of 1 over x cubed dx? Now, when I look at this, it may not be obvious that this fits the pattern, because this 1 over x cubed doesn't look at first glance like it fits this x to the k. So what we need to remember is how this works in terms of negative exponents. So this 1 over x cubed can be rewritten as x to the -3. So when we have something in the denominator, we can rewrite it with a negative exponent. Now that didn't affect at all what we're doing, it just changed one step here. But now it's clear that this does fit the x to the k pattern. This is a power function with k equals -3, which means that k plus 1 will be equal to -3 plus 1, which is -2. So when I take the indefinite integral here, I get 1 over -2 times x to the -2 plus c. Now this is okay for me as a final answer. For some people it'd be really important that you bring this negative exponent back down, and so they would really prefer that you rewrite it as 1 over 2 times x to the squared plus c. But these are algebraically the same. I'm going to be okay with either one right now. Finally, let's look at squared times x to the fifth dx. This is one where if we look at it at first glance, this doesn't look like a power function. This looks like the product of two power functions. But the key is that we can simplify this by using properties of exponents, combine these. X squared times x to the fifth, because these have a common base, I can add, and these are being multiplied, I can add these exponents. So this becomes the indefinite integral of x to the seventh dx, which is just going to be 1/8 times x to the 8th plus c. So we need to remember our algebra, because there are lots of times where we can simplify something algebraically, and it then fits a pattern that we can use.